Hello everyone, I trust you are all as well as can be. Welcome to Frontline Systems webinar on data mining using the power of Analytic Solver plus RASON. Thank you very much for joining us in this virtual gathering to briefly talk about and share some of the possibilities that Frontline Systems software offers to train and validate your machine learning models and create multi-stage workflows and easily deploy them as cloud services. My name is Dr. Sima Maliki and happy to present this webinar. Today with me, I am also pleased to tell you that we are joined by Frontline Systems President and CEO, Daniel Filestra. And Dan will help me with answering all of your questions. This presentation usually takes about 45 to 60 minutes. You're welcome to type your questions in the chat box. This is the GoToWebinar. It has a chat box on the right side, and either Dan or I will try to answer your questions by end of the webinar. Dan just informed me he doesn't have a microphone to jump in and say hi. He will help with the questions though. And after the questions at the end of the webinar, if you like, you can speak up and ask questions, introduce yourself, and talk about your goals and business problems. Thank you for your cooperation. So this is our plan for today. Today, we start with a brief overview of Analytic Solver Desktop and then the cloud version, which allows you to use all the advanced features and capabilities from convenience of your browser anywhere. Next, we switch to Analytic Solver Desktop to follow typical data mining project steps to perform a supervised learning algorithm. Then we practice creating multi-step data science workflows as easy as dragging and dropping icons for each step to train and compare multiple algorithms. After that, we show you how only with a few clicks you can deploy your machine learning workflows to the Azure cloud to run it as a cloud service using Analytic Solver plus RASON. Then we move beyond that and show you how to embed your data mining workflow and create your own web page. And if time allows, I will try to show you some more data mining examples. So this is our plan for today. We start with Analytic Solver tool and then RASON. Analytic Solver could be familiar to, I'm pretty sure, but RASON may not be. In a nutshell, RASON Decision Services is Frontline's Azure-hosted decision management suite. It is the tool that allows you to deploy your models and manage them easily. So we are going to start with creating a multi-step data mining workflow in Excel from data transformation, partitioning to training and evaluating machine learning models. Then I show you how to deploy that data mining workflow as a RESTful service. So we are going to use RASON as our deployment platform. This will allow you to deploy your workflow as a cloud service so that other people can use your model and run them over and over again. So people can actually access your models and or any other application basically and rerun them. Okay, as we go along, we'll discuss more details on deployment and RASON. And I just want you to know that Frontline has made this very easy for you with a tool that's called Create App Feature. It's available from any of our products in Analytic Solver, and it offers in a window into RASON. So let's take a look. Okay, after installation of Analytic Solver, this is the data mining ribbon. Let me close this update request. Okay, so here's the Analytic Solver. Here's the ribbon. And you know that when you install this product, you will access the optimization simulation and then also the data mining section that allows you to perform machine learning algorithms. So let's walk through the ribbon. We have the model tab, get data, that allows you to bring data into Excel using different sources. This allows you to bring a statistical representative sample of data. This could be any other database, or you can work with our Apache Spark Big Data clusters, or use file folder to bring text files into your workbook to perform text mining. While you're here, let me also open the cloud version of Analytic Solver so you can see how similar these two ribbons are, and actually can increase the size much easier. So if you go to your Office 365 and then open one Excel workbook, here I'm just going to open a blank Excel workbook to show you. Okay, so this is my online Excel, and then I can click on, you can see I have already installed Analytic Solver and data mining is available. But if you don't, you just click on Insert and then click on Office Add-ins and search for Analytic Solver, and you should be able to see Analytic Solver tools. Okay, so then you can add them in your Excel and start using them from your convenience of your browser with using an online version of the Analytic Solver cloud version. And with your desktop license, you also have access to the cloud version. You just have to use the same username password. Check out the license from desktop and use it on the cloud version, or vice versa. You just can use your license on one of these. Okay, so here's the data mining tool. Let me increase the size, makes it much easier. So we talked about get data that allows you to bring data into Excel. Then we have the explore tool. This allows you to visualize your data using the chart wizard. You also have the feature selection capabilities. And transform, these are the tools you need to, these are all data handling utilities. You can clean your data, also handle your missing data, bin your continuous data, transforming categorical data, and principal component analysis also available here. Then you have cluster analysis, text mining, and then time series group that allows you to gain insights from your time series data. Then you have the partitioning, standard partition with oversampling. Remember, there's a separate partitioning for your time series data. And then data mining that allows you to perform classification. We have 6 different classification and ensembles of classification algorithms, and also prediction algorithms. These are all the supervised learning techniques. So here is your prediction algorithms and ensembles of prediction algorithms. So with Analytic Solver data mining, you have access to 4 unsupervised learning algorithms, including the 2 clustering methods and also principal components. And here you have access to association rules. You have different charts, and you can access your license, use help to access the live chat, example models, and user guide. So let's perform one adjustive visualization using the cloud version of Analytic Solver, and then we can continue with one of the supervised learning techniques. So let's click on example models. So first, as you can see, it's asking me to log into my account. So I'm going to quickly enter my credentials, click login. Next, it will ask me to check out my license from it says it's currently being used by the same user on Office on Excel. Let's say check out license. Now it's validated, and you can see you have access to different examples, optimization, simulation. Let's click on forecasting, data mining example. For this one, let's just open the iris data set. I want to show you how easy it is to work with the visualization. It says that it's going to create a new document. Let's say yes. And this would be our iris data set. Okay, so now we have one of the example data set available. Let's click on data mining. Make sure you always select a cell within your data, then go to Explore Chart Wizard. Okay, I'm going to introduce the circular with and show you, for example, let's try to have a bar chart. Very simple. You can see immediately chart would form. I can just show you, you can color by one of the categorical variables. Here we have the species name. This is a very nice data set about various species of iris flowers. And I just want to show you too that how easy it is to work with visualization. So you can see, since I already selected the data, it automatically recognizes where my data is. First row contain headers, then you can use different statistics, color by one of your categorical variables, and then have different filters. You have options, and you can use back to select a different chart. So let's go back. This time, let's use a scatter plot. You can have different variables, you can change them. And then you can change the various species lengths. You can see it's very nice. You can size by species lengths, and we also have the coloring. So it's really nice. Work with the visualization. And let me change this page by species widths or even the petal widths. Okay. Then other charts that are available to you, you can use a scatter plot matrix, box plot, parallel coordinates line chart, and much more. Okay, so and also let me show you from the Analytic Solver. This is the Create App button. This is what you can do. This is what allows us to have a version of data mining workflow that will run outside Excel. So with this tool, with the Create App feature, we are only a few mouse clicks away from deploying the data mining workflow to run as a cloud service, which can be used nearly by any application. Okay, next, let's work on a multi-step data mining project and practice a supervised learning algorithm in Excel. So let's go back to Excel. Here's my blank workbook. Again, you can see the ribbon is exactly similar, pretty much similar to what we saw on the online version of the cloud-based version of Analytic Solver. Let's click on Help. So again, from the help button, you can access user guides, example models, and you can also go to education and training to access video tutorials and Solver Academy and much more. So let's click on example models and go to forecasting data mining examples. And I am going to use the wine dataset. I already am using this data set. It was just like creating a practice example. Let me just close this one so I can reopen the wine data set, okay? So example models, forecasting data mining, and then wine. Okay, there we go. Just before following with this example, let me show you another slide. This is about data mining steps. So just reviewing a few basic information for those of you who have not done a lot of data mining projects. So imagine you want to predict a fair market value for a house, or you want to predict how many units of your product a customer will purchase in the future. You want to classify whether an online transaction is fraudulent or not, or an email is a spam or not. So these are typical steps that can apply to any data mining project. After collecting your relevant data, you can use exploration and preparation, such as handling your missing data, binning your continuous data. Then you can find columns of variables with the most predictive power. Then you have to partition your data set to multiple sets. And based on your project needs, you can identify the best data mining approach. You can train your model on one set of partitioned data and evaluate the performance on another. Then you can test various machine learning models and evaluate their performance. So if you want to predict an outcome based on a set of features or variables, you can use classification or prediction methods. But what is the difference? These are both supervised learning algorithms. But predict enables you to identify a value for a continuous outcome. Classify allows you to predict a discrete categorical outcome. If you want to predict patterns and relationships in the data, you can use unsupervised learning methods such as cluster analysis, principal components, and association rules. So let's go back to our wine dataset. Now let's practice one of the supervised learning algorithms. So this is the wine dataset with information about wine samples, including 13 variables that describe different properties of wine from 3 vineyards. Our goal is to assign a wine classification to each record. So you can see we have the type variable, and type variable has different groups A, B, and C. These are the 3 vineyards that these wine samples came from. So now we are going to build a classifier model which would automatically look at this data and fits a model to indicate which vineyard the wine comes from. I'm going to show you how to use the classification tree algorithm. So let's click on the data mining ribbon, and I'm going to show you how to use just the partition during the algorithm. Okay, so click on classify. Let's see. Let's click on classification tree. And you just want to make sure you select the cell within the data so that the automatic recognizes your data range. So now you can see that I have all the variables listed here. First row contain headers. Then in this side, I can choose my selected variable and I can choose my output variable. Type is our output variable. This is the one classification from the vineyards that we want to assign to each record. So let's move that to output variable. Every other variable, all other variables are continuous. I'm going to move them to selected variable. You can always notice that and verify that the classes are 3 according to type variable. Let's click on next. Now, there is a pre-processing option on the top. This allows you to partition your data and also rescale your data. So let's click on partitioning, and I'm going to check this box, and you can see that I am using the default setting for automatic partitioning, 60% in training and 40% on validation. Let's click OK. You have the option to rescale your data. Once you check it, it will give you different types, normalization, standardization, and much more. Next, you have different fitting options for your tree. You can use a tree for scoring, and you can show importance features. I'm going to show you the fully grown tree and other. I'm going to use the default settings to save time. Also, you have some advanced options for prior probabilities. Next, you can access the scoring option. So if you have new data that you want to score and find out what is the predicted or the class for the one sample, you can use the type variable, and you can score on new data in your new data in another worksheet or in a different database and get a detailed and summary report. So let's click on finish to run this classification algorithm. Okay, here are the results. This is the output navigator. It gives you information about different sections of this data mining project report. So you can see that we have the fully grown tree rule. So let's click on that. This gives us the table version and also a visualization of our tree. The first variable is prolane. So you can always hover over your variables and it gives you this decision node information. So if protein is less than 730, go to left. So I'm reading the rule that is presented in the top. And if protein is greater than 730, go to right. So let's go right. So we have a sample, the protein is greater than 730. Then look at total phenol. If it is greater than 2.05, we know that the sample belongs to vineyard A. If it is less than 2.5, then again, there's a cutoff point at 1.24, and you can find out whether the sample belongs to vineyard B or C. So this is how you can read the different decision tree rules. So you can actually increase the size also. Okay, so you hover over them, read the rule and that decision node, and go forward. Okay, let's close that. These same rules are presented in a table format. There is the PMML model. This is the required model that you can use to score your new data. Then you have the training and classification validation reports. So let's look at the classification summary. This is a confusion matrix. The confusion matrix displays counts for cases that were correctly and incorrectly classified in the training and validation sets. As you can see here, all the actual and predicted cases are classified correctly. So the error is 0, percent error is 0. But this was the data, the training data that was used to build this data mining project. So let's look at the validation partition. Remember, I partitioned my data set to training and validation. So now we're going to use the validation to evaluate the performance of the model that we built, or the machine learning model. Now let's look. Total of 10 cases were misclassified, and the percent error is 14%. Now, instead of building one single tree, we can use ensemble boosting methods. Ensemble methods, they usually typically help us build better classification or prediction models by combining multiple weak learners in an attempt to create a strong learner by taking a weighted vote of their individual classifications or predictions. But instead of doing it the same way, I'm actually going to show you how you can create your workflow. Okay, so let's go back to our data. This is the task pane. And if you look, there's a workflow tab. I'm not going to go over the remaining. Model tab shows the model in the outline form. For example, for the data mining, when you run a project, you can see different data, reports, and transformations. The platform, engine, and output, they're more relevant to optimization and simulation. So let's go to workflow tab. I'm going to increase the size so you can see. So under data mining, so very first, we have to tell Analytic Solver data mining, where is our data? Because there are a lot of tabs open here, right? So I have to tell Analytic Solver, where is my data? Then if you recall, we are going to divide or partition our data set to training and validation. And then I'm going to show you how you can run different algorithms, building a workflow. So let's click on Get Data, this plus button. Now I'm going to drag new icon, drag it and drop it into this window, workflow window. It's called source data. Now let's verify. Worksheet is data range A1 to N179, and here are our variables. I'm going to click OK. This is our sort data confirmed. Next, let's partition the dataset. There is a partitioning option. So we have the time series partition, standard partition, and partition with oversampling. Let's drag standard partition and place it here. Okay, this is standard partition. Now we want to make sure we're using the data in worksheet, correct worksheet. These are the variables, so let's select all of them. and click OK. Standard partition. Next, we can use a single classification and also run the ensemble methods. So you can see how you can run multiple algorithms. So let's drag classification tree, drop it here. Now we want to make sure, you can see that it's using the data worksheet. We want to make sure we're using the partition that we created, right? So let's do that. Let's use this drop down, change it to standard data partition. Okay, so we change the worksheet, and then just as we did, type is output variable, and all remaining are my selected variable. I'm going to accept all default settings and click on finish. Now you can see that there is a connection between the standard partition and my classification tree. Now let's compare this with the ensemble random tree. Drag and drop the algorithm icon. Then make sure the worksheet is standard partition that is created by this step. And let's adjust the variables. Type is output variable. All remaining variables are our selected variables. Then click on next. Let's walk through these options. So you can see that partitioning is not active because we already are using the partition data set. Next option is number of week learners. The default setting is 10. You can always increment this number. This is number of week learners that you're using for this data mining project. So this means instead of running one simple classification tree, you're running 10 classification tree, and you can increment this number to any value that you would like. Then you can set a seed, use the week learner decision tree, and then number of randomly selected feature, and much more options. So let's click on next, and then you can just get a detailed or summary report and click on finish. Let me just go back to data, make sure I'm using standard partition. Okay. Let's click on finish. So now that we have done this, you can actually click on this button to organize our workflow, and it brings everything in the middle. There is an option to run the workflow. You could also record the workflow. So there are two ways to build workflow. One is the way I showed you with dragging and dropping. Another one is to click on this record button and then start performing multiple steps and different projects and steps. And what would happen is by clicking this button, it actually records the steps for you in the form of a workflow. So now there's an option to actually run the workflow. So let's do that, and it will execute this all these algorithms for us. So here's the data mining, the classification tree, and I actually want to show you, this is the random tree classification. So let's look at the training, and let's look at the validation. And as you look at the validation summary, you can see that the percent error is reduced to 11.2%. The previous one was like 14%, and I just used the default settings. So the ensemble methods are powerful and typically result in better performance than a single tree. Now that we have reviewed how to build a multi-stage data mining workflow in Excel using Analytic Solver, it is time to move along into deployment using Create App. So you can deploy your data mining workflow to RASON server on Azure. To do that, let's click on Analytic Solver, Create App. As you can see, there are many options allowing your optimization and simulation models to be deployed to the cloud, be packed in Power BI, Tableau, on your own application on the web. But with data mining workflows, you can simply click on Cloud Service, RASON Model. So let's dive in. Cloud Service, RASON Model. Here we can give a name to our model. I call it 1M, and click on Save. Immediately, a browser opens displaying the workflow in JSON language in RASON.com, but you can see that it's actually a graphical version of our workflow created for us in RASON.com. With doing this, our multi-step data mining workflow has been automatically translated into its equivalent expressions in our RASON modeling language. Let me show you all the translation. In this section, you can see there's a button here that switches between this version, the graphical version you're seeing, and actually the model itself in the JSON modeling language. By doing this, just click on that Create App, RASON. Our model is automatically posted to the RASON server. So we just use our data mining workflow as a RESTful service. So let's talk more about this RASON.com. You can see that our wine model is under model tab. So there is a model, all the models that are posted to the RASON service. Okay, these are all the models that I have. And here's the one that we just created here. Okay, it has a version. So there is a output tab here giving you some information about what is happening here. And then you have some execution options on the top. And you can access example models and much more. Again, this is RASON.com. If you recall in the beginning, I told you that we're going to work with two of Frontline System products, Analytic Solver, and this is RASON. And this is the deployment platform that we talked about. So let's walk through this so you can get more familiar. So if I click on this button again, you'll see the formulas and everything in the graphical editor again. So this is the graphical from this grid, and we call this now a decision flow. So you can switch between the graphical form of your decision flow or the RASON language code. This is when you start from Excel. You can always build your own decision flow in this graphical editor. As you can see on this left side, there are options for you to build your own graphical way of actually creating your own flow. So you can build your own decision flow. You can have an optimization model fitting into a simulation model or different data mining steps fitting into each other. And you just with dragging, drop, and dropping these icons. So if you wish to edit your model, you can either do it here, or you can just change the code, or you can just go back to Excel, modify the step, and then repost the model. So as we just saw, with only a few point and clicks, we deployed our Excel workflow to the cloud, the Azure cloud on our RASON server. To solve this model, there are these model execution options on the top. So let me hover over them. Let's see. Okay. So I'm going to just show you this one, and then we talk more about RASON and deployment, and then we will talk more, we will walk through other options. So this is post solve type. I've already posted our model. So let's just click on solve because this is a workflow, and I'm going to show you then here that there are some steps happening as requested. And it is completed. Now in the left side in the model dropdown, you can see that I have our YNM model, and here are the results. So if you just click on this link, it actually gives you all the results. Okay, it just runs the model and brings back everything requested, the ensemble method, the classification method, and much more. And you can all modify what you want to see in the output report. So now let's talk about some more basic information for those of us who are not very familiar with RESTful service, REST API, cloud service, RASON server, or JSON modeling language. and then we come back here and we explore a little bit further. So let's bring our slides back up. If you want to build a web application and have something with its own user interface, if you want to have a model, and then you want to have it deployed for a large number of people, or you want to set it up so it can be run and rerun on demand, this is the structure that you have to follow. Typically, there's an application or the client end, and then there is a front end. On the back end, it needs to talk with the server to post the model, to solve it and get the results, or update the model. So when you send a request to the server, you want the data returned in structured format, and it can be returned in JSON or OData, for example. REST is how this communication over the web is happening. It's the underlying architecture of the web. And when you follow REST rules in your web services, then you have a RESTful service. API, or application programming interface, is the way that connects you and the service. So REST API is an API that follows the rules of REST. RASON is your REST API, RASON REST server. As a RESTful service, you use various HTTP verbs such as post, put, get, and delete operations. When you type a URL into address bar of your browser and you press enter, you are actually performing HTTP GET operation. The web server accepts the GET request and produces a response. Usually it's a HTML plus JSON, JavaScript, or it can be pure JSON or a PDF file or another content type. So you are actually doing this like today on a daily basis. Our RASON REST API operates exactly the same way. When you fill out a form on a web page, say solver.com, and click the submit button, you are performing an HTTPS post operation. The web server accepts the post request, including the post body, which is here the form content, and uses that data in some manner on the server. In RASON REST API, our request like post solve that I just did to solve the model operates exactly the same way. It passes a post body that contains your model JSON, and then, for example, in JSON, and the web server accepts the body, interprets it, and solve the model. So we have the post, we have the put. Put is a little different, and it means just update something that already exists. So say you post the model to the server for the first time, and it creates the instead of model on the server. Then you change something in the model, you just have to use put. You don't need to create post again. Okay, so let's go back to rason.com again. And now that we are more familiar with these terms, let's walk through different standard REST API endpoints that are available to you. So we have the quick runs. They solve the model. This for smaller models. You have the solve that is used for workflows. You have quick solve, optimize, simulate, data mining, decision, and diagnose. Now let's hover over this one. These other model execution options. You can create a new blank model document. You can post rason.net API model. It actually create an instance of the model on the server. This is when you're first posting a model. When you post something from Excel, it automatically does that for you. So remember, we are a REST API, and these are the HTTP functions we use. We post the model, and then we can put the model. This is where you update the model on the server. Then you have these model executions. So you have post, solve type for solving the workflows, optimizing, simulating, and data mining. Okay. Next, you can post stop. So again, remember, it's a REST API, so we're just following those simple HTTP rules. Post stop, and everything is just created here for you. So it's really easy for you to communicate with the server. But this is just one way of communicating with RASON server. So you build your model, post it to the server. There are many ways that you can communicate with the server. This is just one example we created for you, but it's integrated with the Excel that makes it really easy for you to do this. So you can get status. Remember, it was post, put, get, and delete. Get status gives you status of the model. For example, is it completed, not completed? And then you can get the results and much more. There are many various examples available here for you. You can look at the RASON examples, optimization, simulation, data mining, decision table, decision flows, and much more. So you can just like click here and open one of the examples. Okay. So far, we started in Excel, created a data mining workflow, then converted the entire data mining workflow to a RASON decision flow using Create App. We executed the flow on the server and got the results and all the output using RASON REST API. Furthermore, we saw our decision flow in RASON language. This is what you can see now, and also in its graphical structure. Okay, so now I want to show you something else. With only a few mouse clicks, I want to show you how you can create your own web page and embed your data mining workflow that was initially created in Excel in that web page. Okay, to do that, so here's our wine model. I'm going to actually go back to the decision flow editor. Once you're posting creating actually a web application, because this is already posted and creating a web application post another version of model, I have to change the name. So I'm going to give a different flow name. So wine M2. Okay. Then go to create app on the ribbon. Create app. And then you can click on web page. Okay, let's do that. It's asking me, do you want to open this with Firefox? Let's say okay. And now you can see that immediately a browser opens, displaying the newly created web application from our data mining model. As we clicked on web page, the decision flow on RASON.com in RASON language was automatically embedded in this HTML web page. Here we are calling our RASON REST server in this URL. So let me show you, this is the RASON server URL. Here you pass, if you want to pass another RASON model, and then data file. Let's not forget to attach our data file. We are using the wine data set. Once we post from Excel, that's fine, it gets attached. But once we come to create our web page, we actually have to attach our data file. So data file, I'm going to attach my wine sample, okay? It's where you attach your data file. Here is the model. If you recall, this is the flow with the name I gave it. It tells me where the Excel is. You can see it's actually expecting Excel workbook, wine data set, and it gets all the information of what we want to do, partitioning, and then classifications and much more. Down here, you can see we have query parameters, the standard. This is for standalone is when you're actually posting a single model, but we're posting a flow. So you can just delete this and you have solve or quick solve. Quick solve is when actually you do not have a data file. For example, you're solving a simple optimization, create this web page and you just want to run it. And solve is used when you're working, for example, with a workflow like what I have been doing. Okay, it just takes a few seconds and it just runs, and you can see all the results are presented here for our partitioning, running the classification tree, and then also ensemble method with 10 different wiki learners. Each wiki learner is one single classification tree, so all of those are completed on the server and results are presented. And then you can right click actually and view page source. Okay, as you can see, this is the HTML page that uses simple JavaScript. Okay, in the top part. From this part, you can see our RASON model. This is the flow, exactly same code that you saw when we started from Excel and posted the model to rason.com. Right? It automatically translates everything. So this part is our model. Then from here, you can see example of Ajax calls. Like you can see the three different ways of communicating and solving this model on RASON server and getting the results. So this shows you how to make Ajax calls to our server. Again, this is just another example of making calls to RASON REST API endpoints. Okay. So the template for this HTML page is shipped with our software. It sits in your example folder. It's a file called RASON template. You are welcome to double click, open it in a browser. You can also edit it and modify it with your notepad. By using RASON Create App web page, we learn an easy way to communicate with RASON REST API beyond Analytic Solver and RASON from a web application. Starting in Excel, we built a multi-stage data mining workflow. We create a web application embedding the decision flow as a decision service, executed the solve endpoint from our web application and received the results. And you saw that that was just a few point and clicks. We didn't do any programming. So this was just a brief introduction to some of the basic features of Analytic Solver combined with the power of RASON Decision Services as a platform for analytics-powered decision management. Remember that this platform works really easy with Microsoft Tech Stack, Excel, Power BI, Power Apps, and Power Automate. You can build your own web or mobile application using Power App and Power BI, Power Automate. Then you can, and also you can make use of data mining workflow results, which will be featured in the upcoming series of webinars. Okay. Again, this was just an introductory webinar to give you a sense of what you can accomplish. Analytic Solver offers a wide range of tools to make analytic-based decisions. You can access the full power of data mining, stochastic optimization, deterministic optimization, Monte Carlo simulation, risk analysis, and decision trees. Analytic Solver plus RASON is a complete decision management suite that supports the full range of business rules. You can build decision tables, forecasting, machine learning, optimization, and simulation models from large to small multi-stage analytic workflows. We saw today RASON, our decision service, as a platform for analytic-powered decision management, and it works really easy with Microsoft Power Stack, Power Apps, Power Automate, Dynamics 365. I just showed you just a very simple version of what you can accomplish. RASON gives you a lot of power when it comes to data connections, security. It works with JSON and OData, and you can also set different options to actually run and model on a certain time or schedule. So it allows automatic scheduling and all those options that you can imagine that you could want when you're running, and automatically you want to update your model and rerun it on demand or on a scheduled time. So all of these are available in this tool that is really well integrated with Analytic Solver. So if you wish to work from Excel, you can work from Excel and leverage your data modeling skills that are available to you, and then go to RASON, step by step, explore it, and learn more on how to take the most out of it. Okay. I have another just graph to show you what we did today. So we started in Excel, build our model from convenience of a browser. Remember that you can also have your models on OneDrive. So we build the data mining workflow. Then we use the Create App Cloud service to post our model to RASON server. For data mining models, we can only use the RASON model for optimization and simulation. You can actually post your Excel model as an Excel model on the cloud. RASON server, remember that it also opened rason.com for us. We saw the code and we saw a graphical version of our model by just clicking on that create app RASON cloud service. There is much more that's available to you when it comes to all the power of Analytic Solver. And remember that you can have a client that can communicate with this model that I created as a cloud service. You can have your own mobile app, you can have a Power Apps, and you saw that I showed you how to have a web application to communicate with RASON server for optimization simulation. You can also use a Power BI and much more with data mining, but just the examples available also with Power BI. We have optimization simulation examples that you can easily execute, and you can have your Windows or server applications. So with Create App, other things are also covered when it comes to the full power of Analytic Solver optimization and simulation. So this was another way I wanted to show you what we did, what is available. And I trust this webinar was helpful to you. If you're interested, please feel free create your own trial account at rason.com. You will get access with your Analytic Solver trial version, access to rason.com, and visit rason.com help. Remember that it's actually pretty easy to access Rason help. Just go to this is Rason. You can just go to rason.com. You can go to help, and then you can see there is a user guide and there's a reference guide that you can download here. Okay. Then if you go to editor, this is where we actually posted our models, and you can use example models and much more. You're always welcome to contact me at sima@solver.com or consulting@solver.com. If you email consulting@solver.com, creates a support ticket that we can communicate and answer to all of your concerns and questions. And let's see. Okay, great. I trust this webinar was helpful to you. I'm going to take a look. I'm sure Dan has answered all of your questions by now, but you're always welcome to reach out and let us know if you have any questions. Okay, let's see. Okay, great. So, Mr. Matt Fernandez, our new sales development representative, is online with us today. Hi, Matthew. And actually, I'm going to unmute Matt. Matt just flown to join us, and he is with us today. I'm going to allow Matt to say hi. Matt, I'm going to unmute you. Actually, you're self-muted, so you have to unmute yourself. Would you like to say hi? Do you have a microphone? And I can make you an organizer also. Hi, Matt. I think you're self-muted.
Hi everyone. Sorry for the delay, and thanks, Seema. Yeah, I just wanted to hop on here and try to absorb what I can. Hi Dan. Hope you guys are all doing well.
Awesome. Nice meeting you.
Likewise.
Okay, let's take a look at questions. So if you're interested to access a recording version of this webinar, email me at consulting@solver.com. I recorded the webinar and I'm happy to send you a link, okay? You might be able to find some older version of previous recordings on our YouTube channel, Frontline Solvers channel. Okay, thank you very much for your time. We really appreciate it. Certainly let us know if you have any questions or concerns and you want to learn more. An upcoming optimization webinar is scheduled. You're welcome to join us. and have a wonderful rest of the day. Dan, thank you very much for helping with the questions. Really appreciate it. Matt, it was really nice to have you today. Have a wonderful rest of the day. Bye for now.